Hello Professor, we are Group 8 and today we are presenting our final project, which is a cloud native 2-tier web application deployed on Amazon EKS. So our goal was not just to deploy an application but to architect it for the cloud using the 12-factor app methodology, and which involves decoupling configuration, ensuring stateless and securing credentials. So before doing our project, I have already set up Cloud9 environment and GitHub repository. So let's begin our first task, as you can see on my screen, and let's begin. So let's go on our Cloud9 environment, and here I have already set up app.python file. So for task 1.1, let's see, it says receives the location of the background image from config map. So for this, instead of hard coding the background image location, we updated the code to read the S3 bucket, as you can see on the line 20 to 23, and which will be injected later through Kubernetes config map. So let's do our task 1.2. So for this, what we did is like we integrated the AWS Boto3 SDK. Instead of backing the image into the Docker container or making the bucket public, this function uses the ports IAM permissions to securely download the image from a private S3 bucket directly into the container local static folder at runtime. So let's do our task 1.3, which says it logs into that prints out the background image location. So let's go on our Cloud9 environment, and as you can see on line 27, what it does is like we added logging here. So this prints statements outputs the exact location of the background image during startup, which helps with observability and debugging. Let's do our task 4 is pass my SQL DB username and password to the Flask application as get secrets. So for this, what we did is like as you can see on our line 9 to 12, we refactored the database connections to read DB user and DB password from environment variables. So we did that. And for task 1.5, add your name to the header of the HTML, pass it an environment variable using config map. So let's go on our Cloud9, and as you can see here, what we did is like we passed this variable to our HTML templates, and which allows us to dynamically display our final project, which says like developed by Group8 on the web page header. So we did that, as you can see here, and our final part is like to deploy our Flask application, which listens on port 81. So let's go here, and if you go and scroll down to the end, let's go. As you can see, finally we modified this application entry point, so we explicitly configured this Flask service to listen on port 81. So that's all about task 1. So let's do our task 2, which is creating Docker file and test the application location locally in our Cloud9 environment. So we have already created our Docker file, so we'll build that. And as you can see on line 13, we have exposed it to port 81 as per as requirement. So for that, let's try to build our Docker. And see, building the image locally, which compiles our dependency and application code into an immutable artifact. So let's wait for some time. So we are successfully now created the Docker image, as you can see on my screen, which compiles our dependency and application code into an immutable artifact. So now we would map Cloud9's preview port 8080 to the application port through 81. So for that, let's run a command which I have already saved, and so let's enter. So this has been working successfully. So in order to verify, let's go under preview, let's preview running applications, and as you can see, our background images which we saved in like S3 bucket, let's see, which is private, is loading successfully. So I will show you that as well. So let's go on our S3 bucket, and as you can see, I have created this bucket, and in this bucket I have keep background.jpg images which I have uploaded. So as you can see, it's working successfully. So this was all about part 2. So we did that. So now let's begin with our task 3, which is like storing an application in GitHub and creating a GitHub actions that builds and test our application. So let's do that. So for that, let's go on Amazon ECR and we will create a repository. So let's do that. Let's go in ECR and we will create a repository here. So let's give a name and let's click on create. And now let's go on our Cloud9 terminal and so as you can see, I have already created Git workflows with the deploy.yml file where I have already given my ECR repository. So I will push it and then I will verify that. So for that, let's go down and let's git add. Let's commit and let's git push.
Nothing to commit, but that's it.
Let's give me password. So we successfully committed that and now we'll create a pull request and we'll try to merge into our main. So for that, let's go into my GitHub repository and as you can see here, we already got that request. So let's click on compare and pull request. So as you can see, we faced some issue where it was not showing that pull request. So we resolved the conflict and now as you can see, successfully able to push the object and here in the GitHub we were successfully able to create the pull request. So just let the title we have added here and let's create pull request and we will merge it. Let's merge pull request, confirm merge. And now we'll go in action and verify if. And now as you can see here, it's building and pushing image to ECR. So let's wait for some time. We have successfully able to merge pull request and it has been successfully pushed to ECR. As you can see the green check mark. So let's verify. So let's go into our Amazon ECR. Let's refresh, give a refresh. Let's click on this and see if our image is here. So as you can see, our image is successfully loaded here. So we successfully did our task 3. So let's begin our part 4, which is create Amazon EKS cluster with 2 Walker nodes and a namespace final. So let's do that. So let's go into our Cloud9 environment and here we have created our cluster.yml file. So we need to create with 2 Walker nodes. So to accommodate the IAM restrictions of the AWS Learner Lab environment, we are using a declarative configuration file as you can see on my screen. So we define this cluster.yml file which specify the region and we defined here as you can see the instance tab and so let's begin that. So let's run a command. So as you can see it's saying like ESKCT listener, so we will install that. Got the issue ESKCTL command not found, so I just install ESKCTL and kubectl and here I can check the version. So let's try to run our cluster again and we'll see if it works. So let's try to create our cluster and it can take maybe up to 10 to 15 minutes, so let's wait for some time. While creating the cluster we got the error which is like timeout because the API error expired token as you can see on the screen saying that the security token included in the request is expired. So we reconfigured our token and all the access key and we tried to create the node group cluster again, but while doing that we got the issue exceeded maximum wait time. So we find out like what caused this issue. So as you can see it is still saying creating progress, so it says like it's still creating in background. So we try to delete that cluster and recreate it again. It's saying it's deleted successfully, and when we try to create again, as you can see, it's saying like the cluster already exists. So we found out the main issue, and then we troubleshoot, and we again delete, and we tried again creating the cluster, and as you can see, we were successfully able to create it. As you can see on the bottom, it's ready. So let's verify if our port is created successfully. So let's let's run a command which is kubectl get nodes. It will verify us whether if our port is created. So as you can see, our port is successfully created, and you can see both are in ready situation. So this was all our part 4. So we did part 4.
So now before moving to the task 5, let me create the namespace first. So here to paste the code to create the namespace final. So namespace final is created. Moving to the task 5, Kubernetes manifest and deployment. We'll now deploy our application components into the final namespace using the manifest files that we have already created. As you can see, manifest files are over here. So let me walk you through first the config map.yml file. Here, config this file stores our configuration like the S3 bucket name and similarly the secret.yml file securely stores the database password. As you can see, it's included over here. So now let me show you the next manifest file, MySQL. Over here. Here we defined a persistent volume claim requesting 2GI of the storage with the GP2 storage class. This ensures data persistence. Then the MySQL deployment mounts the volume to /lib/mysql. As you can see, that's the mount path. We also expose the database internally using the cluster IP service. Now let me open the Flask manifest file. Here we deploy the Flask app using the image from our private ECR repository. So you can see here. We also inject all the environment variables from the config map and the secret here. Now here in role RBAC manifest file, we define a specific Kubernetes role named CLO835, bind it to our service account. This follows the principle of least privilege, granting our application specific permission to view resources within the namespace. So now before applying the manifest file, we need to install the EBS driver first. So I'm going to install that driver. I have the code ready. I'm going to paste it over here. Yeah, as you can see, it's created. Then we need to create the service account as well. So I'm going to create the service account CLO835. Yeah, service account also has been created now. So the question is that why we are creating the service account. Our application deployment specifically requests this identity, and in a standard production environment, we use IRSA IAM rules for service accounts to grant granular S3 access. However, due to the AWS Learner Lab restrictions on creating new IAM rules, we have configured our cluster nodes to use the pre-existing lab rule. This service account acts as a bridge to satisfy the manifest requirements while inheriting those node level permissions. So now I'm going to apply them all the generated like our manifest files. I have the code command ready for this one. So it is done. Every manifest file has been applied. Since I have applied the manifest, Kubernetes is now creating the PVC deployments and services. Now let's check the status. Yep, here you can see two pods have been created, one Flask app and for next one is for MySQL deployments, and you can see both are ready and running. So the next one is Flask service, the type load balancer with the cluster IP, and another one is MySQL service with the cluster IP. Uh, so and there are two applications that is ready, Flask app and MySQL deployment. So here you can see that load balancer has been created with the which shows the external IP as well. So let me show you from the dashboard. So here you can see there is a one load balancer. I'm going to show you by opening it. Yeah, you can see the load balancer with the DNS name. So I guess for all the part task 5 tasks have been completed.
So now moving up to task 6, I'm going to verify the data is persisted when the MySQL pod is deleted, which is going to create my replica set. So for that, I'm going to head over to load balancer and I will copy this DNS name, and let's check if we can retrieve any information. So this is the background image we can see, and here we're just entering the ID. We can see here that name of the information of employee can be seen here, and we also need to verify the persistent volume, where if the MySQL pod is deleted, it's gonna recreate again. So for that, we're gonna delete the MySQL pod. Here we can see MySQL deployment. This pod is deleted, and after a few seconds, it's gonna be up and running, which we can verify from here. Here we can see that the pod is running recently. So now let's check if we can retrieve the same information that we retrieved before, because after deleting and restoring information, if it's still restored or not. For that, let me check my power cable. Yeah. So when I'm fetching the information, uh, so maybe it's going to take some time. Let's just wait for a second. So maybe we have some cache from before. Let's just refresh, like let's just do one hard refresh, and let's check it again. Since the pod was deleted and created again, it should work now. Oh yeah, now it's working. So yeah, we can see task 6 is like satisfied. We have created this persistent volume. Now moving on to, we're going to skip 7 for now. We're going to add it later. So moving on to 8. So we have successfully verified that the Flex app is running by the using the same DNS here. So this one is completed. And in the ninth task, we have to replace the background image in the S3 bucket and update the config map with the new one. So right now we have this image of these trees, that is background image. We're going to change this image to city. So let's do that. City, and let's save this. So what I'm going to do is I'm going to apply this config manifest here. And we can see that the new file is configured, and here it's required to see that the new image is reflected in the browser. For that, let's just like delete the Flask and let's just try if we can restore the same information. So as we have discussed earlier, it's gonna show a new port up and running. Yeah, and if we check it from the browser, we'll go back to the next back step. Yeah, we can see the image changing. And here, if we try getting the information, we can still see the information of the employee. So that's it for this task.
We'll be doing our task 7, which is bonus, where we'll be deploying matrix monitor and SPA and update our manifest and demonstrate sports auto scaling as a response to the traffic load. So let's do that. So for that, I have already created here manifest as YML file, as you can see on my screen. And now I will show how it works. So let's do that. So first, let's clear my screen and let's begin. So I've already applied manifest that YML file. So let's first see if my code is working fine. So I got the error matrix API not available. So what this error means is like that aggregated API matrix that uh, KTS isn't reachable. So one common reason is that the matrix server, API server, or its backing server is missing or misconfigured. So let's troubleshoot the issue. So let's see if we can find that. So as you can see, we got the error from the server not found. So we can see uh, the matrix API server is not registered. So the Kubernetes API server has no matrix endpoints to route to. So to fix this, now we are going to deploy the matrix server using that matrix.yml manifest, which should include everything like service account, RVC roles, and service that exposes matrix server, as you can see in the course. So we'll be again deploying that. So let's deploy it again. So it has been deployed successfully. So what we can do now is like I'm applying now the matrix server manifest and waiting for the deployments to be ready. So let's see. And once the deployment will be ready, we will see verify the post services and endpoints. So now the matrix service is successfully rolled out. So now let's check the matrix server code. So as you can see, it shows running. So now check the service. So the service name matrix server, which is exposed to portfolio, the port name HTTPS is working successfully now. So now we'll check the endpoints and we'll try to fix the issue. So let's check the endpoint. So now the endpoint subject for the service has an IP address, as you can see, and a port named HTTPS earlier, which was empty, which covers like missing endpoint error. So now we will troubleshoot that issue. So let's first verify that the API service is healthy. So you can see the type is status is true and type is available. So the Kubernetes API servers can now route calls to the matrix servers correctly. So let's see if we can do that. So let's verify and see if it is working fine. So as you can see, this one is working fine, and we can see live CPU and memory usage for the nodes and ports as well. And let's run one more command. So here, this confirms that the matrix service is running correctly and the service and endpoints are now configured successfully. And the API service is healthy and the matrix API is available for features like QCTL top and horizontal port autoscalers. So we did one part and now we'll be also doing the other part of this. I've already created spa.yml file now, so I will deploy. So let's deploy it. So as you can see, it's been successfully deployed. Now let's try to deploy our Flask app as well. So as you can see, the Flask app has also been successfully rolled out. So let's apply the manifest again. Let's get the final. So as you can see on my screen, the minimum port is 1, maximum port is 5, and the CPU utilization time can go up to 50%. And if it exceeds, it can generate the instances according to that as per load. So let's generate some load on Flask service and we'll see how it goes. So for that, let's create some load. So as you can see, we created some load on Flask service, and as you can see, the load is generating, which is saying like container creating, as you can see on my screen. And this BGBox port is sending continuous uh, HTTP requests like to Flask service and port it increasing CPU and Flask ports. So now we'll watch HPA and ports auto scale. So let's watch it. So as CPU utilization goes above like 50%, it will recommend more replicas. So let's watch. So as you can see, the replicas is also increasing. As you can see in the top, there is one, and then when the load increases, you can see the replicas is three. And so in order to verify that, I will also let's go into another terminal and verify that as well. Or we can just show it from here. So let's Control C and let's try to see if when the load decreases, does the replica ports also decreases or not. So for that, let's stop load and observe a scale down. Let's delete it. So now I delete it. Let's go into another terminal. And let's try to see. So it's asking for my username. So let's see. We are just like loading the loads down and we'll see how it goes. So as you can see, when we increase the load, the replica increases. And as you can see on the screen, when we deleted the load generator and when we try to monitor on our second terminal, as you can see, the replica is decreasing. It's came to 1 and the load is less. So we successfully demonstrated our task 7.
So for the next like bonus task, mm, which one is a deployment automation with Flux CD. We have already installed the Flux CD. So let me show you. We can get the, as you can see, Flux system is already installed and it is running. So now to achieve a fully automated GitOps workflow, we moved away from the manual kubectl commands and implemented Flux CD. Now for this part, we'll demonstrate the true power of GitOps. Instead of running kubectl commands manually to update our application, we will push the a change to GitHub and Flux will automatically apply it to the cluster. For this, we are going to change the background image from city to mountain, and we have already saved the mountain JPG file in our S3 bucket. So now I'm going to sorry, the branch that is for we are going to update from this branch. So for this, in our config.yml file, we are making small changes. That is, we are going to change city to mountain, then mountain.jpg, save it. And for now, we have like background image, that is the city. Since we have made the change in this config.yml file, now we'll commit the change and push it to our repository, remote repository. Not and we are not running any kubectl apply commands. So now we're pushing it to git and commit cm background image. Now git using We are going to commit it, push it. So now we go to GitHub to merge this change into the main branch. This is the trigger for Flux. So we are going to Git. Now instead of running kubectl apply manually, we let Flux handle the synchronization. Flux monitors our main branch and ensures that the cluster matches the code. So for this, I'm running the command. So this picks up the new commit immediately. The Flux has faced the latest revision has from GitHub. The configuration in the cluster is now updated. However, since the Flux application only reached the configuration at startup, we need to trigger a rolling restart to pick up the change. So for this, I'm going to copy the command for the rollout. I'm going to copy this command and paste it over here. So it says the Flask app has restarted. Now we are triggering a zero time downtime rollout. Kubernetes is spinning up a new pod with the updated configuration while terminating the new old one. So now we need to run the command kubectl get pods w. Oh, sorry. To see and final. So you can see the Flask app. Its age is 15 seconds, so it has rolled out. So the new pod is running. Now let's verify the change in the browser. Now let me go to this page over here and refresh it. Yeah. So as you can see, the background had changed to the mountain image. This confirms that our GitHub's pipeline is fully functional as we push the code to GitHub and the cluster update itself automatically through Flux. So this concludes our presentation. We have successfully deployed a secure, scalable, and automated cloud native application. So thank you.